Hey everyone, my name is Andrew Ruffin, and I'm a product manager at AMD focused on launching and growing new Azure services built on AMD infrastructure. In this video, I'll walk you through how your infrastructure as a service choices make a difference in your cloud cost optimization journey. If you're not familiar with AMD, we're a major hardware and software provider across all areas of compute. And in the data center, where Azure is a leader, we provide primarily EPYC CPUs, Instinct GPUs, Radeon Pro GPUs, and a range of networking and custom products that tie everything together. You, as a cloud user, don't typically need to worry so much about the hardware. Azure does that for you, for the most part. But you're watching to understand why the underlying infrastructure matters, and where you do have a choice with infrastructure as a service, why you'd want to consider the AMD option to optimize your cloud costs. The Azure and AMD partnership goes back nearly 10 years now, and we launched EPYC in the cloud with our first gen product announced in 2017, which powered the LSV2 Storage Optimized Virtual Machine, or VM. Since then, we've executed year after year, now with around 60 different VM series. Azure also launched AMD's first AI-focused accelerator, the MI300X, which was first in the cloud, as well as the first confidential VMs in the cloud based on AMD EPYC. So when you do have the choice, how do you know if your VM is powered by AMD EPYC CPUs? Well, look for the lowercase a in the name. The vast majority of VMs you'll see have that A that I'm highlighting here, from the BASV2 to the NVADS V710 V5. There are a few exceptions, like the LSV2 I mentioned earlier, and the H-series VMs, which have been AMD only since HBV2 was announced back in 2019. Outside of these few exceptions, Azure has been really consistent in this naming structure for many years now. So when it comes down to it, look for that letter A. Now you may be wondering what all these letters mean. So here's the alphabet soup we live and breathe every day so you don't have to. I won't read through this all, but take a look at the number of VM families you can choose from, and you'll see that it covers just about every workload you might need without having to procure and manage your own hardware and data centers. That's the beauty of Azure, and this is the menu of compute choices that Azure services often choose from as well. In this video, we'll cover the most common VM types, the DA, EA, and FA families, with a focus on the V7 varieties that became generally available earlier in 2026. Before we dive into the details, it's worth noting the sheer scale of what Azure offers in terms of regions and compute diversity. I regularly count the number of Azure regions available and where you can find AMD compute, and as of my last check, you'll find AMD options in each of the 65 Azure-controlled public regions. Most customers will focus on the most widespread general purpose, memory optimized, and compute optimized options. So if you have a favorite region and you don't see what you need, definitely reach out. The general purpose DA family is best for many workloads and comes with either 4 GB of memory per vCPU or virtual CPU, or 2 GB. Look for that little L in the name for lower memory. If your workload can handle lower memory, you're going to save about 10 to 12% on average by moving to a lower memory SKU. These VMs also come with and without local temp disk. Look for the D to see if there's a temp disk. If you don't need that temp disk, you can save 3 to 5% on average by not choosing that SKU. Next are the memory optimized EA family, which increase the memory to 8 GB per vCPU, doubling it. This comes with a 31% cost increase, give or take, so if your workload doesn't need this much memory, then stick with the DA family for sure. One option you might consider here is constrained core VMs. This means if you want to keep cores constant while scaling memory and storage, you can actually do that. This can save significant money on software licenses that charge by the core. Last but not least are the compute-optimized FA family, which come with 2, 4, and 8 GB of memory per vCPU. In this case, you get a full core as a vCPU versus a thread. So these are some of the highest performance options you can get without going to specialized compute options like the H series. These VMs come at a 50% price increase over their corresponding DA or EA series VMs, so it's best to use this for bursty workloads or maximize performance per dollar on workloads with core-based software licenses. Once you've figured out which VM types and sizes are the best fit for your workloads, we always recommend savings plans or reservations to reduce costs further. Pay-as-you-go pricing makes sense only when you're trying things out or you have a very uncertain workload, so absolutely pay attention to the pricing options you have available on Azure. When I speak with customers, it is very common that they're running on 5-year or older infrastructure, whether in their own data centers or on Azure. A 5-year-old VM in Azure would be something like the V5, D, and E series, for example. And many customers are running on even older V4, V3, or even V2 options. So, Let's consider a general scenario of a customer in the retail industry running on Azure. They host their e-commerce system in Azure with their catalog and payments running across a combination of workloads like Redis for web caching to ensure the site runs quickly, a Java application server running their business logic, and a back-end MySQL database serving up new content and recording transactions, shipping information, and more. They've architected their systems to enable serving their peak demand along the lines of 20 million requests per second in Redis, 1 million operations per second in their server-side Java application, and up to 40 million MySQL transactions per minute. When running that system with 16 vCPU V5 memory optimized VMs, those 5-year-old VMs, the business runs across 103 different VMs with an associated cost of $72.18 per VM. That adds up to $743,000 across all of the VMs. I'm using pay-as-you-go pricing here, so of course, you know to use those savings plans or reserved instances, but this is an example. If you move to the V7 VMs, the higher performance means you can reduce your VM footprint significantly, leading to the most significant savings. You go from 103 VMs to 55, nearly a 50% reduction. While the single VM costs a bit more at $79.89 per month, around 11% more, you can reduce spending by around 41% by reducing your VM footprint. So take all of those savings and invest in new Azure AI services or future general scaling as your business grows. Now, let's dive deep into a workload I think is near and dear to many Azure customers, Microsoft SQL Server. And let's see how moving to the newest AMD infrastructure can save in terms of compute and licensing costs. SQL Server doesn't care whether a core is a thread or a physical core, it licenses them the same. What matters is how much work each licensed core can actually do. In this case, we've benchmarked performance using a workload derived from TPC-H, tproc-H throughput, which measures analytical query throughput with multiple users hitting the database. Let's say you're again on that 5-year-old VM, an AMD D32 ADS V5. You can maintain your licensed cores and move to a new VM based on the 5th generation AMD EPYC CPU, the D32 ADS V7. This gives you 39% more throughput per dollar spent on compute and SQL Server Enterprise licenses, with a 41% increase in raw performance. So that's a great option. Maybe you want to reduce costs further and you're willing to give up some raw performance to do it. Well, you have the choice to downsize to a 16-core D16 ADS V7, and that gives you nearly 60% more throughput per dollar spent, even with a 20% reduction in raw performance. Maybe you want to further optimize your SQL Server performance per dollar, so you can then look at the compute-optimized FA series, reducing cores to 16 with the F16 ADS V7. These VMs give you a full physical core, not a thread, which are counted the same in SQL Server licensing costs. With this option, you can achieve more than double the throughput per dollar and still improve raw performance by 11%. I think the FA Series V7 and even the V6 are perhaps overlooked for this capability with per-core licensed software. When the compute is far less costly than the software license, even with that compute cost premium, it can be worth the switch. Modernizing to Azure AMD infrastructure, whether you're coming from a 5-year-old server in your own data center or from a 5-year-old VM on Azure, means you get the same SQL Server database experience with better economics. Why? It's because modern AMD on Azure delivers more work per licensed core. We've covered a good bit of ground, but only really scratched the surface of what's possible. Ultimately, you have many options in Azure, and your choice makes a major difference in your upfront cost, but more importantly, your performance per cost. You have solid options with the V5 as the lowest cost today, but you'll get much more work done for your business per dollar spent with the V6 and especially the V7. So if you're on V5 or V4 for your infrastructure as a service, it's definitely time to look at what's new. For more information, you can check out the AMD partner page, the IaaS landing page, check out the AMD tuning guide for Azure, or the AMD SQL Server tuning guide. And last but not least, AMD offers a new tool called the Cloud Cost Advisor, which I recently took on as a product manager. The tool lets you analyze your cloud footprint to see what you can save by upgrading to newer AMD VMs on Azure. You can see options for the lowest cost, with at least parity performance, options for reducing runtime, and options for downsizing your VMs if performance allows. So if you have any questions, reach out to azure@amd.com, and we'll help you get the info you need to grow your business while optimizing costs on Azure. Thanks for your time, and check out our other videos on confidential computing and high performance.